Hi everyone, so welcome back. Today what we're doing is we're starting our new topic, and our new topic is looking at electricity and magnetism. And you should all have your booklets already, ready to start. So looking at the content in this unit really quickly. Lesson 1, we're going to look at charge and how objects become charged. Lesson 2, looking at current and how we can measure current. Lesson 3 is looking at what potential difference is and how it can be measured. In lesson 4, we'll look at series and parallel circuits. So in Key Stage 2 or even Year 7, you might have looked at circuits, but we're going to look at types of circuits in more detail, so series and parallel circuits. Lesson 5, we're going to look at resistance and how it can be calculated. Lesson 6, we're going to look at magnets and how they interact. Lesson 7, looking at electromagnets, what they are and how we can make them. And lesson 8, we are going to look at what electromagnets are used for. So let's get started. So again, we have all our learning objectives, our glossary and our knowledge organizer. Let's move on to lesson 1. So lesson 1 is how can objects become charged? So straight away, I'm just going to move on to my PowerPoint. Let me just make my screen bigger. So looking at how objects can become charged. So if in your booklets, you could move on to a do now task. I'm going to give you about 5 minutes. This do now task is based on stuff we've looked at already, so like respiration, photosynthesis, and we've gone over this so many times, I expect you all to remember it. Don't worry if there's anything you're stuck with, we will go through the answers to this. So if you just pause the video here for 5 minutes, complete your do now task, and then come back and we'll go through the answers. So, looking at question 1 to begin with, what's aerobic respiration? And whenever you get a question on aerobic respiration or respiration generally, the first thing I want you to think of is what's the purpose of respiration? And when we think about the purpose, you'll remember that the purpose is to get energy. So at the end, you will always have your energy. And then, second thing I want you to think about, what things do we need for respiration to occur? So what do we need to be able to survive, basically? One of the other ways of looking at it is what do we need to survive? And what do we breathe in to survive? And that is our oxygen. What else do we need to survive? We need food to survive. And what do we get from that food? We get glucose. And next thing to remember quite easily is what do we breathe out? So we've looked at what we breathe in. What do we breathe out? We breathe out carbon dioxide. Plus here. And then we have one more thing. And if you remember, we also get water at the end. And that's our equation for aerobic respiration done. Sometimes you can even put this energy in brackets as well. Next question, looking at the equation for photosynthesis. And just like I did for aerobic respiration, I want you to begin this question by thinking about what the purpose of photosynthesis is. And if you think about the purpose of photosynthesis, it's to get that glucose or that food for those plants at the end. And then thinking about what do we need for photosynthesis to occur? What do we need for photosynthesis to occur? So remember, plants need their carbon dioxide. They need water for the photosynthesis to occur. Sometimes we write sunlight here as well, because photo, remember, means using sunlight, photosynthesis. And then we get our glucose. And then if you remember, the plants also release that oxygen at the end. And quick trick to help you with these equations, can you see how Photosynthesis is just aerobic respiration reversed if you forget about the energy because of that's in brackets. But can you see that it's just reversed? So that's one easy way to remember it. I've got this written in better writing, so there we are. Next, what is conduction? If you remember, that heat energy is transferred in 3 different ways. So we have conduction, convection, and radiation. If you remember that from our last topic on energy. Not last topic, a few topics ago. And conduction is when that heat energy is transferred in our solids. So remember, those particles start vibrating and against each other and passing on the energy. And that is your answer to question 3. Next question, how does thermal energy from the sun reach Earth? And if we just imagine this to be Earth and this to be the sun, how will that energy get from Earth? It has to travel through space. And remember, space is a vacuum where we have no particles. So if in conduction, let's just go through these 3. So it has to be one of these 3. Can it be conduction? No, because we need particles to be able to vibrate against each other. So it cannot be conduction. And can it be convection? No, it can't be convection, because remember, that's when the liquid or the gas particles are rising and then forming that convection current, so it can't happen. And if you remember radiation happens when those waves pass on that energy, and we don't need particles for that. So the answer to question 4 is through radiation, and you can remember, as there are no particles in space for conduction or convection to occur, so it can only be radiation. Looking at our challenge next, what is the difference between a dependent and independent variable? So this is all the way from year 7, looking at working scientifically. So if you remember, our dependent variable is the variable we measure in an experiment, and our independent variable is the variable we change in an experiment to see its effect. Let's go on to get started with our lesson. So some of the learning outcomes for this lesson are to state the types of electric charge, to describe how objects become charged, to explain how charged objects interact, and to explain what is meant by an electrical field. So, to begin with, we can't do our pair talk, but just thinking about this by yourself for a few minutes, what do these 3 images have in common? So I'm going to give you a few minutes. If you can just pause the video if you need more time. What do they have in common? And if you got that they all have some sort of static electricity, and because of that static electricity, that balloon is able to stick to the wall. Because of that static electricity, this child's hair is all up in the all up everywhere, whizzing around. But you might have heard of static electricity before. You might have seen videos of it happening. But where does it come from? What is it? That's what we're going to look at today. And if you remember, we have this in your atoms topic from year 7, when you looked at atoms, we spoke about different types of electrical charge. And electrical charge can either be positive or it can be negative. And if we have charges that are the same, or if you can say like charges, or the charges that are the same, they repel each other. And so if we put 2 positive charged objects near each other, they'll repel each other. If you put 2 negatively charged objects next to each other, they will also repel each other. And if you've ever used magnets before, remember we have those poles. Don't worry if you haven't. If you've ever used magnets before, if you put the same type of pole next to each other, it will repel. And if you put the opposite poles of the magnet together, they will attract. And this is kind of similar to how that magnet acts. So like charges repel, or the same charges repel, opposite charges will attract each other. So a positively charged object, for example, if we have any objects like a balloon, if that's positively charged, and a wall, I'm just going to pretend that's a wall, if that's negatively charged, they will stick to each other because they're attracting. So any objects that are opposite will attract, but if they're the same charge, they will repel. And this charge, where does it come from? So if you remember, everything is made up of atoms. So all particles are made up, or everything is made up of atoms. And atoms are made up of those subparticles, so our protons, electrons, and our neutrons. If you remember, even from, we looked at this in the periodic table as well. And that proton is positive, that electron is negative, and the neutron is neutral. So if you remember, the atoms are neutral, so they're going to have the same number of protons and electrons, and when they have the same number of protons and electrons, the charge cancels out to make the charge 0, so they're neutral. But when these protons and electrons become unbalanced, so they have extra electrons or an extra proton, the object becomes charged. So we've already been through this question. So atoms have an overall net charge of 0. So what does this tell us about the number of protons and electrons they have? They have the same number of protons and electrons, and they're neutral, so they're not charged. So atoms are neutral. They have no charge. So for example, if you have a balloon, normal balloon, really bad balloon, it's not going to have any charge. But if this balloon was to gain a proton or gain an electron, then it would become charged. But a normal balloon will have no charge because it has the same number of protons and the same number of electrons. We're going to look at a few examples of this now. So if we have a look at this example of a balloon and a jumper, in the beginning, so a normal jumper and a normal balloon are going to have the same number of protons and electrons, so the same number of positives and the same number of negatives. Let's just count this together to make sure. So how many positives are there? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 positives. And how many negatives do we have in the jumper? 1, 2, 3, 4, 5, 6, 7, 8. So 8 minuses. And if you remember in maths, if we have 8, so positive 8 minus 8, it's 0. And because it's 0, it has no charge. So the jumper has no charge. Let's have a look at the balloon now. It has 3 positives, so 1, 2, 3, and 3 negatives. If we do plus 3 minus 3 in maths, we get 0. So this balloon also has no charge. But if we were to rub the balloon and the jumper together, what happens is some electrons move towards the balloon. So some of the electrons from the jumper are going to travel to the balloon. Let's have a look at what happens. So here we have some of the electrons missing. So we still have 8 of the positive charges, so 8 plus, but the minus charges we only have 3. So if we do our maths calculation again, if we have plus 8 minus 3, we are left with plus 5. And plus 5 is a positive charge. So to answer question 1, what charge does this produce? Sorry, we've gone on to question 2 to begin with. What charge does this produce on the jumper? It produces a positive charge. because we have a +5. Let's have a look at the balloon now. The balloon is going to have 1, 2, 3 positive charges, and then 1, 2, 3, 4, 5, 6, 7 minus charges. If we do +3 minus 7, what do we get? We get -4. So it's going to -4 is a negative charge, so it's going to produce an overall negative charge on the balloon. And if you remember, when we looked at how our charges interact, a positive and we have a positive jumper and a negative balloon, and they're opposite charges, so they are going to attract. So just to summarize that again, we have a minus charge on the balloon, a positive charge on the jumper, so opposites interact, so that balloon and jumper will start sticking to each other as a result. And hopefully that makes sense. Now what we're going to look at is we're going to observe charge happening. So we're going to see what happens to this lady's hair when we charge it.
11:30 show. Yes, the penultimate period. That means the second last period. That's because our line has been closed from 1 p.m. That's in about half an hour from now. Okay, so you're going to hold hands, ladies. You're going to put your hand on that ball right over there. You got, oh, it's shot. Yeah, I know. It's been once a lifetime. All right, there's the before. Now, yeah, you already got hair standing up a little bit here. I got a really good feeling. Okay, here we go. 3, 2, 1, and you're going to start to shake. Yes and no, no and yes. Oh, man. All right, stop shaking.
Okay, so what's happening to the hair? What effect does static have on hair? And what can we say now that we know about those charges, about what's happening? Give you 30 seconds to think about it. Pause the video here, think about it, and then come back. Okay, so what's happening is that when she's touching this big ball type thing, I don't know what you call it, metal ball, it's charged, right? What happens then is her hair becomes charged. So all her hair particles become charged, and the hair particles will all have the same charge. So if they have the same charge, they are going to repel, because the same charges repel each other. So we know in terms of charge and repulsion, what's happening is that her hair particles have become charged, and it's the same type of charge. So those hair particles are repelling each other. So they want to move far away from each other. So her hair sticks up and spreads around. And you probably have seen this before in TV shows or documentaries, etc. So let's move on. We've got a few learning checkpoints. So after I read every question, pause the video, think of your answer, and then we'll look at what the actual answer is. So what is everything made up of? If you got atoms, you are correct. Next question. Atoms are made up of what? If you got protons, neutrons, and electrons, you are correct. Next question. What charge does a proton have? If you said positive, you are correct. Next question. What charge does a neutron have? This was a trick question. If you said neither, you are correct, because neutrons have the neutral charge. They have no charge. What charge does an electron have? If you said negative, you are correct. What is the overall charge of an atom? If you said, I'm not sure, you're correct, because it's neither, it's not positive or negative, it is neutral, so they have a neutral charge. What do opposite charges do? They attract. Next, what we're going to look at is we're going to have a look at lightning. And if you haven't already, please go and watch this video you have the link on your booklet. So if you just type that onto your browser, watch this video and come back, and then we'll talk about lightning. So pause the video here, watch the lightning video and come back. So how does lightning happen? When we have a cloud, a storm cloud, air is moving around constantly, and the movement of that air does, it creates regions that have a positive charge, and it creates regions that have a negative charge. And electrons are jumping from the positive region to the negative region, and from the negative region to the positive region. And this electrons jumping from one area to another, what it does, it produces a really big current. And this current heats up the air and produces lightning. And that is how lightning is produced. And you would have seen that explained in the video as well. And that's why you see lightning. Next, looking at electrical field. So you might have heard of gravitational fields before, but electrical fields are quite similar to gravitational fields, but they're slightly different. So if you can see, these are pepper grains, and these pepper grains have an electrical field around them. And what an electrical field is, it's when you put a charged object in a field and a force acts on the object. So if you put a charged object in an electrical field, a force will act on it. So we have these pepper grains. If we put some charge in alongside these pepper grains, a force is going to start acting on these pepper grains and cause them to react like how they are in this video. So here they are repelling each other, so moving away from each other because they're the same charge. So that is explaining what an electrical field is. Next, what I want you to do is I want you to go ahead. So I have a table here, but these are the same questions that are in your booklet. So if I could ask you to go to your booklet and complete your activity questions on there, try the challenge as well, do as much as you can. And this is everything that we've looked at so far. So going ahead and completing your questions. Next, just to look at some answers, I'm not going to go through all of them, but just some. Question 1, the answer is positive and negative. Question 2, repel and attract. Question 3, atoms. Question 4, positive. 5, no charge and negative. Even number of charges. Electrons transfer to the balloon. The positive charge on the jumper and negative charge on the balloon. Electrons move from negative regions to positive regions, creating a current, which makes that lightning. An electrical field, a force will act on an object and move it. And I'll put up more detailed answers and the answers to the challenge questions on Show My Homework for you all to look at. Hopefully that helped. So now we know what the two types of electric charges are. We've described how objects become charged. We've explained how charged objects interact. And we've explained what we mean by an electrical field. So that's our learning done for today. Well done.